Hello and welcome back to my channel. Dear students, this is the fourth video in continuation with the other three videos where we have been discussing the questions based on general properties of matter which were asked on the 29th of January 2024 JEE mains. Okay, so I have collected all the questions from morning as well as evening shift together. There are about 5 to 6 questions in this video, all related to general properties of matter. Okay, so as you know, students, I have been giving you shortcut tricks as well as the techniques and the methods to solve the question in the least possible time. So please keep watching to my channel and kindly subscribe it. Please do follow for the best results. Okay, all the best. So starting from question number 17, student. As you can see that given below are two statements. If a capillary tube is immersed first in cold and then in hot water, the height of capillary rise will be smaller in hot water. Statement 2 states if capillary tube is immersed first in cold water and then in hot water, the height of capillary rise will be smaller in cold water. In the light of above statements, choose the most appropriate form. Now students, as you know that in hot water, okay, the surface tension decreases. This is a very basic phenomenon, students, because as you know, hot soup, okay, hot pudding, hot tea or hot milk, hot coffee, all these taste excellent, as compared to the same substance in colder state, because since high temperature, hot bodies, because of high temperature, the surface tension will be less. Surface tension of water decreases. So they are able to spread more on the taste buds of the tongue. And so more of that, stuff which we are eating or which we are sipping, it comes in contact with the taste buds of the tongue. And so they appear to be more tastier. So surface tension decreases with increase in temperature. So if the surface tension decreases, then capillary rise must decrease, because as you know that capillary rise is the formula for capillary rise. If H is the capillary rise, then this is 2t cos theta, where theta is the angle of contact from this. So you can see H is proportional to surface tension. So in hot water, surface tension will be less, so rise will be smaller. So statement 1 is correct, students. Coming to statement 2, it is just the opposite. Okay, it is just the opposite. So statement 2 is wrong. So we'll go with the third option, that is statement 1 is true, but statement 2 is false. Moving on to question number 18. A wire of length L and radius R is clamped at one end. If its other end is pulled by a force F, its length increases by L. If the radius of the wire and the applied force both are reduced to half of their original values, keeping original length constant, the increase in length may be given. Students, just observe the way I am solving, and exactly you have to do the same thing in the exam hall. This question should not take more than 1 minute. Absolutely, this should not take more than 1 minute. Very simple. So I am solving this, just see, students. So first of all, what you have to do, you have to write the formula interlinking this length, cross-section radius, the force, increase in length. Of course, everything seems to be very clear, and it seems to be an apparent topic from elasticity. So we'll go with this formula, students. Basic formula: stress is equal to y into strain. This is the basic formula. Now stress is the restoring force per unit area. Okay. So when equilibrium is attained, restoring force will be equal to the applied force. So here I am taking the value of applied force itself. You have to understand this. And the strain is increase in length upon original length. This is the first step you have to write, students. Then coming to the second step. Let us confirm what all things are constants. So you can see if the radius of the wire and applied force both are doubled, both are reduced to half of the original, keeping original length constant, then the increase in length. So we have to obtain an expression for increase in length. So our next step will be to identify all the quantities which are constant. So naturally, y is a constant. Okay, students, because it is the same material. Then keeping the original length constant means this capital L is also constant. So we can clearly see that the increase in length is directly proportional to the ratio F by R square. This will be the next step, students. Okay, next step. Now we have to find the factor of change. Increase in length will become factor of change for L we have to find. So factor of change for L will be equal to factor of change of F upon factor of change of R square. Okay, students, see the technique. Factor of change for L. What is the factor of change of F? It is clearly given that force is reduced to half. So I will put half here, and also radius is also reduced to half. So that I will put it here half. So finally you can see you get 2. So that means the increase in length or the elongation will increase 2 times the initial value. Okay. Is it clear, students? So in fact, if you are expert enough, you can conveniently and comfortably solve this within 30 seconds as well. But it requires a little bit of practice. Okay. I usually coach my students to solve these kind of questions in this way itself. So my students are always habitual. Okay, in the entire 2 years, that is class 11th and 12th, I make them get habitual to these kind of techniques. Alright, moving on to the question number 19. A small liquid drop of radius R is divided into 27 identical liquid drops. If the surface tension is T, then work done in the process will be. Now students, work done means what? Energy required, energy invested in that. So as you know, when a big drop gets divided into smaller droplets, surface area increases. And as you know, the molecules residing on the surface, they require additional energy as compared to the molecules which lie well within the liquid. So if they require additional energy, they have to get energy from somewhere or other. So external agency has to do work. So whenever a big drop splits up into small droplets, energy has to be supplied to the system so that the surface area increases. And as we know, for every unit increase in area, the energy required is numerically equal to the surface tension. Again, I am repeating, students, please listen. For every unit increase in surface area, the work done or energy required will be equal to surface tension. So that means what? The work required will be surface tension multiplied by increase in area. So this is the answer. So that means what? Increase in area will be final area minus initial area. And since there are drops, they will have only one surface, the outer surface. So if I take the radius of small droplet as smaller and radius of bigger drop is already given as capital R. So this should be the answer. Okay, students. So a big drop of radius R gets splitted up into several minute droplets, small droplets of radius smaller. So here we have to express smaller in terms of capital R. As you can see, all the options are in terms of capital R. So we will equate the volume, students. So 4 by 3 pi R cube is equal to 27 4 by 3 pi small r cube. I have cancelled 4 by 5. This is how you are supposed to solve. 4 by 3 pi r cube is the volume of the bigger square, and 4 by 3 pi small r cube is the volume of the smaller square into 27. I have cancelled 4 by 3 pi, so I have not written. Now extracting the cube root, we can see it is this. So I can write small r as capital R by 3. Therefore T into 4 pi will take outside. So I have 27 into small r square is capital R square by 9 minus r square. So as you can see, this will be 3. So 3r square minus r square is 2r square. So T into 4 pi into 2r square. So that is 8 pi r square t. That is the answer, students. So that's how you are supposed to solve it. It should not take more than 1 minute, of course. Then moving on to section B. In a test experiment on a model aeroplane in wind tunnel, the flow speeds on the upper and lower surfaces of wings are 70 meters per second and 65 meters per second respectively. If the wing area is 2 meters square, the lift of the wing is. This kind of a lift is known as aerodynamic lift. Aerodynamic lift, because the air will apply a kind of upward force because of the movement of the body. As you see, students, aeroplane, before they take off, they have to acquire certain speed, because unless they acquire that speed, they won't get that aerodynamic lift. Okay, this I am talking only for aeroplanes, not helicopters, because helicopters, they work in altogether different principle. Similarly, jet planes, they work on another different principle. I am only talking of aeroplanes. So, suppose this is a plane, okay, this is a plane, and these are the wings. So, as you see, if it goes like this, then the air will be flowing in this direction. So as you can see, the upper wings has 70 meters per second velocity. I take it as V1, and the lower surface has a velocity 65 meters per second. Okay, students. So we'll apply Bernoulli's theorem for horizontal flow. Even though there is a minor level difference, we'll ignore this level difference. So here, let us say the pressure on these wings. Here, pressure here is P1. Whereas here the pressure is P2. So applying Bernoulli's equation for horizontal flow, I can write half rho of air into V1 square plus P1 is equal to half rho air. Remember, we are applying this to air. Air is flowing opposite to the direction of movement of the aeroplane. Okay, students. So I have rho air by 2 into V1 square minus V2 square is equal to P2 minus P1. So this gives you the difference in pressure. If you multiply it by area, you will get the aerodynamic lift. So aerodynamic lift will be P2 minus P1 into area. So P2 minus P1 is density of air by 2 into V1 square minus V2 square into surface area. Now density of air is given as 1.2, that is 12 by 10 upon 2. V1 square minus V2 square. So I will be applying, students, A square minus B square formula, which is A minus B into A plus B. So this will be 135 into 5, and as you can see, area is 2. Okay, students. So 2 gets cancelled here, you can see, and we will cancel 5 2s and 2 6s. So final result will be 6 into 135. So 6 5 is 30, 0 carry 3, 6 is 18 plus 3, 1 carry 2, 6 1 is 810 Newton. So we have 810 Newton is the final answer. Now students, in section B, as you know, you have to calculate and get the answer. Okay, you cannot guess, or you cannot do any kind of any logical rationalization will not work there. Finally, you have to get the answer because they require the final answer. Coming to question number 22, two metallic wires P and Q have same volume and are made up of same material if their area of cross sections are in the ratio 4:1 and force F1 is applied to a P and extension of delta is produced. The force which is required to produce same extension. Again, student, just now we solved one of the question. Same technique we have to apply here. Okay, I'll again start with the basic formula, that is stress is equal to Y into strain. Now stress is the restoring force per unit area and strain is the increase in length upon original length. Okay, students? Right. So you can clearly see two metallic wires have same volume and made up of same material. Material is same. So Y will be same for both. Now we don't have any information regarding the length, original length, but we do have information regarding the volume. So in the next step, what I am going to do, I am going to replace length by volume by cross sectional area. So if you replace this, okay, you have F by A is equal to Y into L capital A by B. Okay, students. So the force, because we have to find the ratio of force, so force can be written as Y upon B into L into A square. So now let us identify the constant. So Y is a constant because Y is same because it's made up of same material. Then in order to produce same extension, so extension that is increasing length is also same, and it is clearly given that volume is same. So that brings us to the conclusion that the required force to be applied, which will be same as the restoring force, because as you know, students, we allow some time to get settled. We allow some time for the wire to get settled. So always make it a point that restoring force will always be equal to the applied force, assuming equilibrium conditions. So we have this. Okay. So the ratio of force will be the square of ratio of areas, and ratio of areas is given as 4:1. So square of that will be 16:1. It will be 16:1. Okay. That's all, students, in this video. Thank you so much for watching my channel. Please do subscribe to my channel and hit the like button.